Cammy's not loading. You might have to just do it on the PDF itself, then edit the PDF. I wonder what the deal is with Cammy today. It's so weird that stuff has been weird lately, and I think it's when we're going through it's the stuff coming through Google Classroom that's the issue. I kept trying to grade stuff yesterday, and I would grade everything, and then I go hit return all of them, and all of my grades would disappear. So I think there's an issue in terms of Google Classroom, but I'll give it a minute for you guys to. Is anyone else having any trouble uploading the form or downloading, I should say? So all we're doing today with this form is we've talked about different forms of quadratic functions. And what I really want is for you to have this sheet where you see the differences so that you can recognize them. When we come back, we will fill out a form that's more problem solving. But this is kind of a cheat sheet so that you can recognize what kind of a quadratic that you guys actually have and the graph of those quadratics. So if we're looking at the parent function, if you remember, the parent function is just f of x equals x squared, right? That's the function that we're working off of this entire time. Anything else that we're doing, the standard form or the vertex form, those are just manipulations of that parent function, right? They're things we're adding to it or subtracting from it or multiplying it by, but really that base function is just x squared. And it creates a U-shaped curve that we call a parabola. Parabola. I'm going to make this a little bigger for you too. I know you're looking at it on the... The axis of symmetry is a vertical line that divides the parabola into two equal parts. That's that center divider in the parabola, right? Where we talked about if it folds over on that line, those two sides would line up, and it's why when we... Yes, it is being recorded, Dylan. So far, I'm still on that screen, so it means the recording's still working. So it's that turning point, right? That folding point that we know everything is the same on both sides. It's why when we find that vertex, we only have to find the points like on one side or the other of the vertex because we know they're going to be the same on the other side. That axis of symmetry is the reason that happens, right? The turning point is called the vertex, right? And so because this is a parent function, we can just make our vertex 0, 0 because we know that at x equals 0, y also equals 0. Because if I plugged 0 into x squared, I would get 0 back. And then we're going to pick points, right, on both sides of that vertex. And when we plug them in, if we have negative 1 squared, I get 1. If I have negative 2 squared, negative 2 times negative 2 is 4. Here we would have 9. And these would repeat in the opposite order, right? Because that's what symmetry is, right? They're going to be the same on both sides. And when we go to graph those points, we would have a point here. We'd have a point at negative 1, 1. We'd have a point at 2, 4. We'd have a point at 3, 9. And that is going to repeat coming over in this direction too. I feel like I put that at 3. I feel like that 1, 2. Yeah, that point should be here, not there. And here I'd have the same thing, right? I'd come up here to 4 and I'd have a point, and I'd come up here to 9 and I'd have a point, and you'd see that this would be a smooth curve. A lot of you guys were making it a V, and I can understand why, because I just kind of did as well. But it's not really a V, right? It's a curved shape, which is kind of hard to do when you're writing on a computer. I understand. But I just want you to understand that it's kind of a curve. It's more like a U than a V, right? And so that is our parent function. Everything that happens elsewhere is just being moved from that standard form or whatever, right? Like we talked about it, especially when we were discussing the vertex form, because that vertex form shows us the different movements. Like if we look at this vertex form right here, we know that this right here would be moving to the left one space. This -2 out in front would show me that it flips over the x-axis. It's a reflection over the x-axis, and we would be multiplying everything by 2. The 6 on the outside means that we're moving it up, every point up 6 places. So everything is really just stuff that we're doing to that original parent function, that x squared. The standard form of a quadratic equation is that of the form f of x equals ax squared plus bx plus c. And when we want to find the axis of symmetry on this, we would say that x equals minus b over 2a. So if we are looking at this equation here and we want to find that axis of symmetry, which is the x value of our vertex, we would go, okay, well, that's minus b, so that would be minus -4 over 2 times a. Well, that's just 2 times our a value is 1, so it'd be 2 times 1. And we could go that is 4 over 2, which is just 2. Right? So that's going to give us the x value of our vertex, and I would place that in the middle. And then to find the y value, I would have to plug in this 2 for all our x's. So this would be 2 squared minus 4 times 2 plus 1. So we would get 4 minus 8 plus 1, which is -3. And then we would plug in points around it. 1, 0, -1, 3, 4, 5. And I'm not going to plug in all those points, but you would plug each of those in for your x values to get your y value out. But I already know what they are, so I'm just going to go 6, 1, -2, and these are going to repeat. This is going to be -2, 1, 6. And then we can go ahead and plot all those points. At -1, I have a point at 1, 2, 3, 4, 5, 6. At 0, I have a point at 1. At 1, I have a point at -2. And then at 2, we have a point at -3. And we know that is our vertex. So it's going to start coming back up, right? I'm just moving over 1 each time, and I'm lining up those dots, and we can. This is a terrible graph, but you know where the dots are. I was just supposed to actually touch all of them when I connected it. So we've got our parent function. We've got our standard form of a quadratic function, right? And now the last thing that we have to talk about is the vertex form, which should be the freshest in your mind, right? So that vertex form is just f of x equals that a times x minus h squared plus k, right? And this is the one we've spent the last week looking at, right? The axis of symmetry is h, right? It's whatever h is, not negative h. It's whatever h is. So if h is 4, if this says x minus 4, x would equal 4. If it says, oops, I wrote 4 because that's what I was thinking. If it said x plus 4, we would know it's negative 4 because it would have changed the sign. So I always like to think of it as the opposite of what's in there, right? Like when we're talking about the vertex too. So this would be x equals h. And the vertex is always going to be the opposite of what we have here. So if it's minus h, it's going to be h. And then exactly what we have here for that value. So if I am looking at this equation that we're given, I know that the vertex is going to be negative 1, 6. The axis of symmetry is always just the x value of the vertex. So it's going to be x equals negative 1. And this is where we know to start our table, right? This would be negative 1, 6. And then we plug in the different points around it. We'd have negative 2, negative 3, negative 4, 0, 1, 2. And then we would plug in, again, all of those numbers for x to see what our y is, right? I'm not going to do all the math on that because this is just a note sheet. Here we would get negative 12. Here we'd get negative 2, 4, and then this would repeat. This would be 4, negative 2, and negative 12. And I know it's going to repeat because it's symmetric. I can tell you something about this right here. That negative there means my parabola is going to be upside down, right? And then we just plot our points. Now, I don't have a 12, so I'm going to start at, let's see, 1, 2, 3, 4. This is going to take me like probably up here a little bit, right? Then my next point is going to be at negative, oh, sorry, I lied. It's not going to take me there. It's going to take me down, not up. Negative 12, not a positive 12. So at negative 4, we're going to have a point, say, down here at negative 12. At negative 3, we're going to have a point at negative 2. At negative 2, we're going to have a point up at 1, 2, 3, 4. At negative 1, we're going to have a point up at 6. And then it's going to start coming back down again. And you can kind of see how that works. So this is all I've had for you today. I want you to submit it. I want you to save it and submit it. If you couldn't do it, print it and do it. If you couldn't open it in Kami, I don't know what to tell you. I would say when it will load for you, because I can't help if it won't load, just kind of go to the end of the video, Adon, and write it down a little bit later. But the rest of you, get it submitted before you leave here. All right? Make that your last thing. I'm going to stop the video now because I'm not going to say anything else about any of this.